Before we wrap up this section, there's a few more things we need to talk about. Let me go ahead and delete out this code. We could play with it a little bit, but let's talk about some specific things. So the first thing I want to talk about is kind of the notation we use to create arrays. In the previous video, I wrote something like this: int bracket list equal new int, and let's just put in there 10, right? So this is the code we wrote in order to actually create an array for the first time. So let's compile this. Everything looks good. This actually isn't the only way we can create an array in Java. The alternative is something like this: int list, we'll call list2, bracket equal new int of 10. Let me compile this so everything looks good. So this is slightly different notation. In the previous example, what we did is we had the brackets associated with the int, right? So we had int, bracket, list, blah, 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 blah. Here what we've done is we've moved the brackets over to the variable name, right? So now we have int list2 brackets and then blah, 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 blah. So both of these are valid ways in Java that we can create an array. You're free to use whichever one you want. For myself, I would always recommend the first one, right? This to me is the better one. The reason for that is that this bracket notation, that bracket is really, to me, typing information, right? It's telling you what is the type of thing that your list variable is, right? That's the same thing that int's doing, right? Int is telling you something about that variable. It's telling you, oh, that list variable, it's an integer, right? It's type information, right? It's telling us about what type of thing that variable is storing. From that perspective, int and brackets, because they're both pieces of type information, they should go together, right? We should write int bracket, then our variable, and blah, 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 right? We want to keep related things together. If we write it the second way, well, then I have some type information in front saying that, oh, it's going to be an integer variable. Then I have the variable name, and then I have the type information tells me it's going to be an array, right? So my type information is split across two places. So for me, I would consider it to be better and more natural to keep all my type information together, right? So just write int bracket. But if you want, yes, you can do it the other way. Okay, second point, initializer lists. So what we have right here, right, are examples of me creating an array for the first time when a program is running, right? Maybe I don't even know how big it's going to be until the program runs, right? Remember we saw earlier that we can actually use a variable to define the size of my array. And initially, the values inside there, right, we showed that they were all equal to 0 initially when we did the letter count example. But let's say I wanted to create an array, and I knew exactly how many elements would be in it from the very start, and I knew what values I wanted to store into it. Well, in that case, there's actually something I can write that'll let me do that kind of very easily in Java. So let's create a second list variable again. And then what I'm going to do here, instead of using the new keyword to create a new object, is I'm going to create an initializer list. So I'm going to use here my curlies, right? So these are my curly braces that typically we see when we have a method. And inside of these, I'm going to type in my values. So this, right, is an array that contains the numbers 1, 2, 3, 4, 5, 6. Let me actually change this up. Let me make this a 5 over here, a 2 over here. There we go. And we can even print this out, right? So this is going to actually work exactly like any other list of ints. Even though I'm using a little bit different syntax to create it, it's exactly the same thing, right? It's still an array of values. So let's compile this. Compile is fine, and then let's run this. 1, 5, 3, 4, 5, 2. All right, so this is looking good, right? The key observation here, right, is that I'm actually defining the values in my array right in my program, right? We're not using an array to set it up. We actually have typed in, the values that I want to initially set my array to. And after I do this, right, I can also change stuff in my array, right? So I can always go list at index 0, right, meaning the first element where the 1 is right now. I can always go in and set that equal to something like 999, right? And if I compile this and run it, I'll see the updated stuff. Now over here I have my 999, 53452, right? So this is just another way to create arrays where you want to populate them with things ahead of time, right? We don't want to do things when the program runs. We want to do it ahead of time. So this is just another way to set things up. Let me do one more example of this, just so you don't start thinking that arrays are only for ints. Let's do a double. So over here we could do this. Let's go 1.1, 3.3, 5.25. And over here, let's update this. Go list 3, and then we'll say that's a double inside, double D. D again over here. Compile this. Getting an error here. It looks like I left out a comma. Go ahead and put that in. Compile this. Run this. Over here we get 1.1, 3.3, 5.25. So works the same, right? So I can do this with any data type, right? This could even be characters or something else, right? Or even strings. One of the nice things about arrays, right, is that you can essentially mix and match their syntax with everything else, right? Any type of variable can be used to create an array, and then therefore, whenever we want to set up an array, whether we're doing a new blah 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 or actually doing an initialized list, we can put in whatever type we want, right? We're free to choose. But let's actually look at kind of one thing we haven't used arrays for, which is using them as parameters to methods. So let's clean up our code a little bit. Let me go back. I just want list 2. We'll go back to just having the ints. And let's see what happens if we try to use this with a method. So let's go list 2. And I'll just create a very simple method here. Let's go public, static, and let's call this thing display array. So this will be a method that takes in one array called A and then prints it out. And I'll talk about this in 1 second. Display array of A. All right. Over here I have a new method called display array, and I'm calling it over in my main. I'm calling it on A. That's not quite right, is it? Really, over here I should be calling this on list 2, right? So my new method, calling on that list variable, right? That array I created, and we'll see what happens. Over here inside of this, what I've done, right, is I have my public static because I want to create a method that I can access from over here. And over here, let me actually add in the word void here. It doesn't have any return. Display array. And then over here, in order to take an array as an argument, what I've done is I've used that bracket notation again, right? So this is similar to when we actually created the array up top, right? We went and we said int, bracket, then list 2, and then we set it equal to something. Well, over here, we're doing just the int bracket, and then we have a name for it, right? So this is how we signify to Java that we want to pass in an array as a parameter to a method. So inside of this method, from here on, A is an array. So then it acts like an array. For example, we can use a for each loop to loop over everything inside of that array. So over here, right, I've literally just copied and pasted the code from earlier. So this is going to look at everything inside and then print it out. So if everything works, right, this will compile and we'll get kind of the same results as we had last time, right? We'll get this stuff here. Let me actually clear that out before we run it. Then we run it, and here we go. 9995345. So this looks pretty good, right? I'm allowed to pass around arrays as parameters. One kind of caveat here. Let's say that in our display array, for whatever reason, right, this really shouldn't be here, but let's say we had something like this. Inside of our method, we had A, right, the parameter that was brought in, bracket, and let's say index 1 equal 480. So this here, right, is updating the contents of the array. Now, if you think about just variables in general, you might think, oh, this doesn't really do anything, right? That number doesn't change, it's over in the main. Unfortunately, that's not quite what's going to happen here. If I run this, I'll get the same output, right? 999534552. That's fine. But then look at this. Let's do another println, and we'll put in the main this time. And then we'll go println list2 at index 1, right? So this is the index that it looks like I was trying to change in my display array method. So let's compile this and run it, see what we get. 99953452480, right? So notice that even though I'm back in my main and I'm doing a print on the original variable, right, the list2 variable, it's showing me that 480. So the key thing to realize here is that there's only one array out there, right? That parameter that's being passed to the method, that's not passing a copy of the variable, right? It's not passing a copy of the array like it would do if we just had an int or a double or something. It's actually passing a reference to that array. It's really passing something that's an address that says, oh, this is where you go in memory to get access to the information inside of that array. That's what it's doing right now. That's the way it works in Java. So this is something to keep in mind, right? Any changes we make to an array inside of another method, the whole world will see them, right? The outside, anybody, whoever else is using that array will see those changes. Sometimes that's a good thing if you want to communicate with other parts of your program. Sometimes it's a bad thing, right? If something changes something that it shouldn't have. In addition to this, there's one other thing that can happen. You could also imagine doing something like this. A equal new int, and let's just call it, let's say it has 15 things inside of it. So this may be, right, is a different way we might accidentally or purposely try to change an array in a method, right? So we could do this. So we can compile this really quick. And maybe think to yourself, what will happen, right? Will this just display as 0 because the list 2 got replaced with a new array? Or will it display something else? Let's run it and find out. 9, 5, 3, 4, 5, 2, 5. So what happens here is I'm still displaying the original value, right? So initially I had 5 in the index 1, and over here when I printed it out again, right after I ran that method, it was still 5. So nothing changed. So over here what's really happening is that this a equal new int 5, this is replacing the value inside of a, but a, right, the parameter, that's a reference to that array wherever it is stored in memory, right? So it's going to put in a new address into this a variable, but the scope of this a variable is on this display array method here. Back in my main method, that list2 variable, that is still referencing the original array that was created in memory, right? We haven't changed the address that variable is talking about, right? It still knows about that original array. That array reference, right, or address was only updated within this method. If you want to change stuff inside of an array, that'll work just fine. It'll show up everywhere else in your program. But what you can't do, right, the thing that's not allowed is for you to set a equal to something new. Right, we can't change the entire array, right? We can only change the stuff inside of the. If we wanted to change the stuff, we would need to do something slightly different. We would need to have this array be a return type. So I could do this. I could do, let's say here, public static int bracket, and then over here, what I would need is I would do a return a, and over here would go list2 equal a. So what this is now doing, right, is we're printing out our a. We're creating a completely new variable, right? We're creating a completely new array, and then we're returning that array because this change over here, right, didn't affect the outside. So instead, the way to get around that is to return a, and then over here, right, the new a, that's the value it's returned from this method, and so that then we would want to store it into the list2 variable. So if we compile this and run this, we should get back a 0 instead, right? Because we've built out a new array and we've used it to replace the list2 array that main first knew about. And that's what we see, right? So we see our 999, our values being printed out, and at the very end, right, we see that 0 being printed out because list2 has been replaced with the new array that was created within the display array method and then assigned to list2. So there we go. The key kind of takeaway is that arrays act like objects, right? They are objects, right? They're passed by reference, not passed by value, like primitive types.